Hello and Assalamualaikum. This is my mini project ECS 338 poster presentation. So, for this poster is about the technical drawing of my mini project. So for the first picture is roof plan. The roof plan have two dimensions, which is A to C and 5 to 1. So the dimension for AC is 15,000 and 5 to 1 is 22,000. The next one is first floor plan. The first floor plan show A to B and B to C have equal dimension, which is 7,500, and 5, 4, 3, 2, 1 have also have the equal length, which is 5,500. The next one is ground floor plan. The ground floor plan have the same dimension like the first floor plan, which is A to B and B to C is 7,500, and for the side 5, 4, 3, 2, 1 have equal length, which is 5,500. The next picture is side view plan. So for the side view, the span show that the length of the full span is 22,000. Each panel or each slab have also the equal length, which is 5,500. So for the fifth picture is the front view plan, which is show the truss length. The truss length is 2,500. Each length have equal length of the truss. So for the last view is the 3D view. So the next poster is about the design details. So for the first design, we need to determine the load from the truss and the RC floor. So the truss GK is 0.5 kN/m², QK is 0.5 kN/m², and we get the NED is 1.425 kN/m². So for the purlin GK is 0.25 kN/m², QK is 0 kN/m², and we got the NED 0.338 kN/m². So for the point load truss is 19.594 kN. The point load for purlin is 1.859 kN. So the total point load that we get is 21.453 kN. So the ultimate vertical load from the roof truss is 128.719 kN. So for the slab GK we use is 7.425 kN/m². The QK is 3.69 kN/m², and the NED that we get from the roof truss is 15.964 kN/m². Then, after we determine the load from truss and RC floor, we can calculate the steel column design. For calculating the steel column design, we need to determine the total load, which is the NED. So the NED that we get is 113.575 kN. The area required is 3.199 cm², and the area is 38.3 cm². So from the UKC, we use the column size of 152 times 152 times 30. So for the web, I determine the web is class 1, the flange is class 1. So for the overall class for the steel column design is class 1. For the compression checking, the NED over NCRD is 0.08, which is below 1, and the result is pass. So for the buckling checking, we have two axes, which is ZZ axis and YY axis. So for the NED over NBRD is 0.2, is below 1.0, which is the result is pass. The NBRD that we use is from the ZZ axis because the ZZ axis have the lowest NBRD value, which is 489.5 kilonewton. So for the next part is steel beam design. For steel beam design, we need to determine the design action first. So we get the design action is 15.964 kilonewton meter square. So from the UKB, we use the beam size is 254 times 102 times 28, which is the WPLY is 316.188 centimeter cube. So for the MED, we get is 112.247 kilonewton meter, and the VED is 59.865. So for the classification of section, which is it have web and flange. So for both section, we get the class 1 section. So for the overall, for the steel beam design is class 1. So for the shear resistance checking, we get 0.164, which is it is below 1. So the result is pass. After we check the shear resistance checking, we check for the resistance to shear buckling, which is the answer is 38.159, and there are no further checking for the resistance to shear buckling. For the bending checking, we get 0.896, which is the value is below 1, and the result is pass. So for the flange buckling, we get 38.159, which is below 216.035. As for the result is pass. For the web buckling, which is the FRD value is 98.792, which is higher than the VED value, which is 59.865 kilonewton. As for the result is also pass. The last one is the deflection chart. So for the D actual, we get 19.422, and D allowable is 20.833. The D actual is less than the D allowable. So for the result is pass. So for the final design is we define the beam and column connection. So for the beam and column connection, we use the capacity of bolt, which is the FVRD is 723.84 Newton, which is higher than the NED, which is 113.567 kilonewton. For the bearing resistance, the FBRD is 712.68 kilonewton. It is have a bigger value than the NED, which is the NED value is 130 kilonewton. For the welding resistance, which is the FWRD, is 132.77 kilonewton, which is it have the also the higher value than the VED beam. The VED beam value is 59.865 kilonewton. For the shear resistant beam, VED over VPLRD must be less than 1.0. Thus, 59.86 over 162.71 is equal to 0.37, which is the value is less than 1. As for that, the shear resistant beam is pass. The shear resistance plate VCRD is 565.82 kilonewton. So we use the largest value, which is 565.82 kilonewton, is higher than the VED value, which is the VED value is 59.86 kilonewton. So finally, as for the conclusion of the mini project ECS 338 is we have determined the load from truss and RC floor, the steel column design, the steel beam design, and the beam column connection.